Welcome to the Agronomy and Farm Management Podcast. I'm Amanda.
And I'm Elizabeth. Thanks for joining us today.
Hello, everyone, and welcome back to the Agronomy and Farm Management Podcast. Today, we're going back to talk about some weather topics. We have Dr. Aaron Wilson with us. It's been a little while since we've had him on, so we are going to do a quick look back and a little bit look forward to what winter is bringing, and then we're going to start with some myth busting. So hang around for that. It's going to be exciting. So welcome, Aaron.
Great to be here. I appreciate the opportunity to come back and talk. I noticed you didn't call me your favorite guest this time, which might be a first, and I figured after back-to-back drought years and all the challenges that we've had that I've sort of lost that title.
Yeah, that's probably true. Why don't you give people a little bit of title information on your position in case they haven't listened to us before?
Yeah, so I'm the Ag Weather and Climate Field Specialist for Ag and Natural Resources in the Department of Extension at Ohio State University. I'm also the state climatologist for Ohio, so not only delivering weather and climate information to our agricultural producers across the state, but focused on all sectors: transportation, energy, health, and just anywhere that weather and climate information can help improve decision making. That's really kind of what I focus on.
Yeah, it's great to have an expert like you in-house. I know you're one of my favorite people to text in season about weather questions. So it's great to have you on tap all the time here. Well, and then now that harvest is wrapping up for just about everybody, I know there's a few people who are listening who may have a few acres still out, but I think we're almost done across most of the state. I think now's a pretty good time to take a quick look back at what 2025 looked like for everybody.
Yeah, so of course, I already alluded to drought conditions. We had a historic drought, especially across southeastern Ohio last year, and a little bit later in northwest Ohio. And we waited a really long time throughout winter to get some soil moisture recharge last season. But it did finally arrive. We had fairly wet conditions, really wet conditions actually in April and May for a lot of folks in Ohio. 3-month span of more than 30 inches in places like Pickaway, Ross County that got hit particularly hard. And we had our 8th wettest April through July on record, going back 131 years here in Ohio. And what was the kind of combination challenge with that was the cold May conditions, right when folks need to get out. So now we've got, moist surface and very cold conditions, so there were some challenges there. And then we transitioned really rapidly to very warm conditions, especially in overnight low temperatures. Throughout the summer, we didn't have a lot of 90-degree day temperatures and nothing out of the ordinary, but really record warmth when it comes to overnight lows in both June and July. And along with that, and really because of this high humidity factor, we were talking all-time warmest overnight lows and high humidity, where we spent, for instance, at Dayton International, we measured, more than 66% of our hourly observations in June and July had a dew point of 65 or warmer. That's muggy. Yeah. And 35% of the time at 70 or warmer dew point, which is oppressive. And so we just had those really high humidity levels and a lot of moisture around. And it turned on a dime. We had locations in August not receive a drop of rain for the entire month. So August was the driest August on record over the 131-year period. And then we finally started to moisten up again in southern and eastern Ohio as we went through this past fall. But drought remains. 11% of the state still covered by extreme drought conditions in northwest Ohio with, really low pond levels, farm ponds, historical low flows across the Maumee River Basin. So really missing out on the water up there. So we're ending another year, back-to-back year, with drought conditions in the state.
Which seems pretty unusual for Ohio.
Yeah, droughts are, they're a natural part of and cyclical part of our environment. We see droughts really quite often. It's just, over the last few decades, we've seen really intense droughts over shorter periods of time. Nothing like we saw if you look in Ohio's drought history in the 30s, 50s, 60s, these multiple year, multiple season clusters of drought, which is what this looks like, right? It looks a little bit more like what we saw back in the 30s and in the 50s, but the magnitude even of this drought is still not near what we saw and experienced in Ohio in the 1930s or even in the 1950s and 60s.
Well, and I think the other thing that's really notable is you mentioned it, we were incredibly wet early in the season still, leading up to that drought. We've been digging through some of the seasonal data with e-fields and looking at how delayed planting was from it being wet. When we think about how dry it was, we almost forget about how different just one half of the season was to the other.
Yeah, I think a lot of the reports that reflected those differences, when it came to both the variability of the weather conditions and the timing, then, we had, cornfields that were in vastly different states, vegetative reproductive states across the state. And even within this, some counties where you had, April planted stuff and June, early June planted stuff made quite a difference.
Yeah, and I think even our listeners are probably seeing that reflected in their yields. A lot of times having that planting date spread has caused, some fields did really well this year, whereas other fields, the yields reflect the challenges that we had with those drought conditions. It was kind of like a lottery of where your fields were located and what you got this year.
Yeah, we really saw that in Madison County, and I think that April planting window we had, there were some farmers that went for it and others kind of held back. You just, hindsight's always 20/20 in farming, and that's always a challenge. But there were drastic yield differences from those early planting to late. And I think it just speaks to not that anyone would have made decisions differently given the information we had at the time, but we just keep reiterating being ready to plant when conditions are good, because you never know when you're going to get your next window.
Yeah, because we didn't have a choice. Looking back at the planting progress, I've never really seen it in the trends before. We had a 3-week period where in Ohio, statewide, we stood still. We would get maybe a couple % a week. Yeah. And that was most of the month of May that nobody could, wheels couldn't turn because it wouldn't quit raining, which isn't all bad in hindsight because some of that moisture got some of these fields through the early stretches of those drought and got us through pollination.
Yeah, back in the spring when we met and talked about the outlook for the growing season, I didn't see necessarily a drought on sort of the, compared to last year. I didn't see any of those conditions. Of course, you never really can forecast the driest month for a state. That's not something you typically forecast being that extreme, but that early season wetness, probably saw a lot of folks through.
Well, I was thankful for this fall after the pretty miserable summer we had. That humidity was insane, but we were able to make good harvest progress, it seemed like, for the most part, and had some nice fall weather until it turned this bitter cold that we've had the last couple weeks.
Yeah, but I think everyone in this room on this podcast loves winter and loves snow, and we've certainly, got a good start this year. Here we are sitting almost mid-December recording, and thinking about, multiple snowstorms already, and really one of the coldest Decembers probably in most of our, lifetimes in this region. One of the coldest Decembers, certainly top 10 coldest Decembers on record as we've gotten started here. So we'll see what the last 2 weeks of the month look like. Right now, they do look warmer, unfortunately, for snow lovers on Christmas. We'll see. Obviously, folks will know what went on for Christmas when they listen to this podcast. But right now, it looks like it's going to be warmer to end out the month. But this winter is going to be a lot of up and down. We've talked about La Nina in the past on this podcast. That's what we're in. We're in a La Nina situation. It tends to be very active, which is good for replenishing soil moisture, and that's what we really need this winter. Whether it's rain or snow, that will replenish the soil, and Northwest needs a lot of it. Some areas are 9 to 12 inches below normal over the last 6 months to a year. That's a lot of soil moisture to recover, right? All of that's, you don't want it all at once, and so we need an active winter, and I think that's what we're going to get.
All right, well, let's get into some myths and do a little myth busting here. So one that I think a lot of us have heard is it can be too cold for snow. What do you think about that, Aaron?
Yeah, so, it's we see this a lot. Well, we haven't seen a lot of really, really cold temperatures lately, but, the thought is that, it can be cold, which typically when it's cold, right, it can be less likely for snow to occur with extremely cold temperatures, but it can still happen. Temperatures in Antarctica get a lot colder than they do here, and they still see, what they call diamond dust, or very small particles of snow that fall. And we have, we can see snow obviously at any temperatures. So colder air typically does not, the best way we can kind of describe it, it doesn't necessarily hold as much moisture, right, as warm air. So it can make it more difficult to form snow. If you don't have a lot of moisture around, that can inhibit some snow. Matter of fact, or the system, not even thinking about too cold, but anytime you've got dry air near the surface, it can really cut into your snow totals, which makes forecasting snow in the winter really difficult. Because if you get a period of drier air at the surface, as that moisture is falling through, it can evaporate, and couple hours where you were expecting it to snow, you can take an inch or two off that forecast. So no, it's a myth. It can it can snow when it's really, really cold, but you certainly do need the moisture around to be able to do that.
So sticking with the theme of cold, one that I deal with in my household is that going outside in cold weather can make you sick. Can you settle this debate for me, Aaron?
Yeah. So I'm a meteorologist, obviously, and not a virologist, or don't study, in the medical field. But no, this is, in fact, is also a myth that obviously, I hope my grandmas aren't listening to me, right? Because you want to make sure that you're bundled up and protected from the cold. Obviously, for other reasons, you don't want to suffer hypothermia or frostbite or those sorts of things, which the cold can obviously do. But when we think about colds and flus, these are viruses, right? And they're transmitted mostly people to people, particles, and those sorts of things. And so, viruses, the reason why they happen in winter is because they're not resilient to warmer temperatures. So we often see more outbreaks in the winter for those two reasons. It's a little bit cooler, so it's not too warm. The viruses survive, and we're usually around a lot of groups of people, right? And so we're transmitting it as they evolve, and more people get sick. But you can get hypothermia and you can get frostbite when you go outside, but it's not going to give you a virus just by going outside. So no, that's also false. Cold weather makes you more susceptible to the viruses perhaps, but just going outside doesn't make you sick.
Awesome. So what you're saying is when the weather gets cold, get outside where it's less people-y.
I think that's wise.
So this next one I was really surprised by. I spent many a summer in my youth watching heat lightning in the evenings, thinking it was some phenomenon of it being hot. And if you haven't heard that term, it's that lightning you can see off in the distance that is silent and just kind of lights up the horizon a little bit. So that is actually not a thing.
Yeah, so heat lightning, well, it's a thing because we've termed it a thing, right? So basically when, heat lightning isn't a special type of lightning. It's lightning, obviously, a discharge of particles in the atmosphere. So, a lot of times in the summer, thunderstorms get pretty tall, 30,000, 40,000, even 50 or 55,000 feet in the atmosphere. You get these huge cumulonimbus clouds. So the taller it is in the atmosphere, right, you can see it from a farther distance on the surface of the earth than you might if it was a lower thunderstorm, what we call a lower or capped thunderstorm. So, that lightning is still taking place. And when lightning happens, you get thunder, right? It produces thunder. That thunder starts out as sort of a shock wave in the beginning, and then it dissipates to, what we typically call thunder. But at some point, right, that thunder is originating from a distance so far from you that it dissipates by the time it gets to your ear. And that's what heat lightning is lightning that has occurred and thunder has happened, but that thunder does not reach your ear because the thunderstorm or where that lightning occurred was so far away. The other thing too is kind of the opposite of this is, you can't have lightning in blue skies. Oh. So you actually can, because lightning can travel up to 10, 20 miles away from a thunderstorm cloud. So you'll see this a lot. We talk about blue sky lightning. It could be completely blue sky. You can't see any clouds. But that lightning bolt has traveled from a thunderstorm that may be 10 or 20 miles away and actually have hit and struck people that aren't aware that there's a storm even going on. So, you've got both sides, right? You've got lightning a storm you don't even see, lightning can strike, but then heat lightning, yeah, you're dealing with lightning that's still there. It's just the thunder dissipates before it gets to your ear.
Perfect. That's just what I needed, was some anxiety around getting struck by lightning when it's not even storming, Erin.
Well, this is a good reminder that when thunder roars, go indoors, right? You never want to be outside during a thunderstorm, regardless if you're a meteorologist and you're chasing tornadoes and you're in love with it. Nope, you need to, obviously, you need to get inside. A lot of us love watching storms. I mean, a lot of folks love thunderstorms and such, but lightning is something I try not to mess with. It's something that does kind of weigh heavy on me when I'm outside during a storm.
So the ones we've covered so far have been somewhat lighthearted. Some of the myths that we want to talk about today are maybe tiptoeing a little closer to the conspiracy theory side of things. And one that we've seen a lot on the news and social media lately are the myths around what those white stripes in the sky are. Especially, I feel like we see them in the mornings and they persist throughout the day. Erin, would you be willing to take on this question and explain what it is we're seeing and why it's not something we should be scared about?
Yeah. So, this is something that understandably folks are seeing a lot of this phenomenon in our atmosphere. And what you're referring to is what we call a contrail. So this is a combination of two different words, a condensation and trails, right? So condensation, typically contrails are formed, right, when hot water vapor that's generated by the combustion of jet fuel, right, interacts with cold air at the elevation that the flights are taking place. And essentially what you get is that water vapor quickly condenses as it exits, the plane, and it freezes into these white cloud of ice crystals, right? And so, these contrails are essentially made up of what you would find in natural clouds, because clouds are condensation and that have adhered to different particles like dust or salt and become, liquid droplets, except for these take on that sort of straight line appearance, right? Because they are, again, because of the combustion of the jets. Sometimes you can watch contrails form on planes and they dissipate rather quickly. And that is a good indication that the planes at that flight level are flying in an area where you don't have the atmospheric conditions that are conducive to keeping that condensed and frozen water vapor around. So typically it's a very dry atmosphere. And when it's dry, then you get a lot of evaporation of that condensation or those ice crystals very quickly, and the contrail is really short. During periods where you've got high humidity levels at 30,000 feet where jets are flying, or taking off at different levels as well, then that environment is not trying, it's an environment that's not going to lead to rapid evaporation of those ice and condensation particles. And so those contrails can exist and sit there for a long time. And then depending on the wind speed and the wind direction, over time they can fan out and look sort of like this natural haze, right? And we have a lot of flights, 45,000 flights per day in the United States, and we've got a lot of planes. So, as you go into Columbus in the morning, 8:30, 9 o'clock, you've just got this tick-toe zigzag pattern all over the place because you've had a lot of flights taken off. The environment is one that's allowed those contrails to remain there a while. But most often as the atmosphere warms up and gets overturned, the atmosphere in the upper levels dries out and those dissipate over time. But sometimes you do have, opportunities to persist in terms of those contrail coverage.
This is something I think, getting into the conspiracy theory thing, that people get confused with chemtrails, or we've heard that term before. And can you explain maybe what that means, and is there evidence to support or deny chemtrails?
Yeah, so again, this is, forming a word out of two words, chemicals, and trails. Again, so the idea here that evidence is pretty overwhelming to debunk this theory that government agencies or other organizations are purposely spraying chemicals in the atmosphere. There are a lot of outputs from the combustion of jet fuel. When you think of carbon monoxide, carbon dioxide, sulfur, nitrogen oxides there, I mean, it is pollution coming out of the back, and they are a pretty big emitter. And as a matter of fact, with all the contrails, there's long-term studies showing that those can have an effect on the atmosphere and warming effect as well. So those emissions do contribute to those kind of warming conditions overall. But no, there's been a lot of alleged activities that governments trying to control population or involuntary vaccinations or mind control. This is going back to HAARP as well, which was a small National Science Foundation study to look at the ionosphere 30 to 600 miles up in the atmosphere and look at how that interacts with what's happening at the surface. But there's no scientific evidence or credibility that links these things to what's happening at the local level. And the other thing this gets kind of wrapped into is that it's part of also weather modification. Weather modification is a thing, right? The most common type that we see from a weather modification perspective is cloud seeding. It's often done on a very limited basis. Kind of the myth there is that you can create a cloud out of the blue or out of the blue sky, which you cannot. You need the atmospheric moisture there available, and cloud seeding is part of, inducing usually like a silver iodide particle that condensation can then grip on and induce some precipitation. So you'll see it in the west in some dry, arid areas. You'll see it used to maybe limit some hail production across the west as well. So that the idea is that if you can get the cloud to precipitate, then you can limit the amount of overturning and hailstone creation. And then we also see it in some of the dry areas where they're trying to induce a little bit more precipitation and snowpack into the mountainous regions of the Southwest and the Western United States, but very limited, right, in terms of scope and not very efficient. These techniques aren't very efficient. You're not going to create a cloud. You need the basis of a cloud there in order to do it. But, a lot of times folks think that these contrails are spraying chemicals linked to weather modification and changing. So it's kind of evolved into this really big nebulous, and it's good to be skeptical or think about things that you see that maybe you didn't see as much in the past, and we can talk about that as well. But ultimately there's overwhelming scientific evidence. I can certainly say from my perspective and the perspective of the State Climate Office that there's no known purposeful government weather modification and chemtrail activity that's taking place. And so it's important to share what we know from the evidence, to share what these actual processes are, and to help folks understand and really put us at ease that, these things are not taking place.
So can we talk a little bit more about weather modification? Because I didn't know that was even possible until I think a couple years ago we talked about it. So you said it's really inefficient and it probably costs a lot of money to do.
Yeah, it does. NOAA, for instance, doesn't do any weather modification. You can look back that there was a Weather Modification Reporting Act of 1972 that was put in place. Requires that anybody who intends to engage in any type of this weather modification activities, including cloud seeding, has to report to the administrator of NOAA within 10 days of that activity. So they know what's taking place in terms of these cloud seeding activities, and that's made public, right? But NOAA doesn't modify the weather. This also stemmed out of some, between 1962 and 1982, NOAA did provide support for some research that was called storm fury. And the idea here was that the support was to research whether we could modify hurricane intensity. And the research was not successful at all in modifying any hurricanes with storm fury, and they discontinued it. And since then, NOAA's not attempted to modify hurricane intensity or participate in cloud seeding activities. And so, yeah, I mean, when you deal with the cloud seeding, again, there's a lot of research going on at places like University of Wyoming, some colleges in Colorado to try to understand, where these can take place. I know they've done some stuff in the Middle East as well. The other dry, arid places is where you often hear it. We get a lot of inquiries here in Ohio. Like, we're in a water-rich region that is in no need of of cloud seeding, right? No cloud seeding activities are taking place really east of the Mississippi River, right? Because it's such a water-rich region. And so, again, these are limited scale. You're talking on the scale of a single cloud kind of thing, not something that's widespread, but it's important to say, yeah, weather modification exists, but it's in a very limited box, limited area with limited funding to support that as well.
Well, I could definitely see some farmers being down for this if they could do it over their fields. Like if it's small, you're saying it's small, but we just need to get the scale and the cost of it cut down.
Yeah,
so
and there's
farmers
other,
can do it on
right,
an individual level.
Right.
Cloud seeding via drones.
Yeah.
There's still folks out there with hail cannons too, and the idea being you can shoot a hail cannon, which sends a shock wave up into the atmosphere and can disrupt the formation of hail. Some orchards and some other areas use that too.
And that works?
There's not really strong evidence that it works efficiently or well, but I would say, there's probably not enough to be as definitive, in terms of research, but it's out there. It does exist, yeah.
Well, this is pretty interesting. I'm sure it's got a lot of people's wheels turning in their head. So if they want to look into some of these topics a little bit more, do you have some resources they could go and look into?
Yeah, NOAA's got some really good information and some links about weather modification claims, and different ones we didn't talk about, radar, and solar engineering and some other things that folks might think about. So there's some good information from NOAA there. We're planning to create some. I'm planning to create some materials for extension eventually, maybe in our fact sheets kind of thing. So look for that. You could also reach out to the State Climate Office. My email is wilson.1010@osu.edu. I'm willing to engage in any respectful conversation about the topic and to listen to what folks have to say. But so we can always get more information after that as well. And there's plenty of more weather myths too that we can talk about in the future. I'm sure we will, but we'll leave our woolly bears alone though, right?
Oh, we didn't get to that one, and that one's your favorite.
Yeah, there are certain ones that I want to choose to believe, so maybe we shouldn't ask the questions.
Well, Erin, again, thanks as always. We appreciate your time and your knowledge base.
Yeah, I appreciate being here, and we'll see you in late winter getting ready for planting season.
Sounds good.
Thanks for listening to the Agronomy and Farm Management Podcast. Join us again in 2 weeks for our next episode.